This is Mr. Hassan's Maths channel. I'm now answering question number 4 from the October-November 2022 Cambridge 9709. This is the Pure Mathematics Paper 1, Variant 3. This question is about differentiation and related rates of change. It says a large industrial water tank is such that when the depth of the water in the tank is X meters, so they've defined the depth as being X. Let me just so the depth is X. They've called the depth X meters. Okay, the volume in meters cubed of water in the tank is given by the volume equals 243 minus 1/3 times 9 minus X in brackets cubed. Water is being pumped into the tank at a constant rate of 3.6 meters cubed per hour. So water is being pumped into the tank. So it's going to be like an increasing volume. So we can say that the rate of change of volume, dV dt, meters cubed per hour, is equal to 3.6. Now this is meters cubed per hour. Okay, meters cubed per hour. And this is in meters cubed, and this is in meters, depth is in meters. So those are the units here, right? It says find the rate of increase of the depth of water in the tank when the depth is 4 meters, giving your answer in centimeters cubed per minute. Now this is something where I think many students must have messed up for two reasons. One, because they didn't read the whole question. They find the rate of increase of depth of water. Okay, khalas, I've read the question and I'm going to answer it. They find the answer and they don't convert the answer into centimeters per minute. Here, everything's in meters, meters cubed per hour. So they don't. The final answer, when we use these numbers here, is going to be in meters per hour. Okay, we have to end up with centimeters per minute. So some people, they didn't read the question, so they didn't realize that's what you have to do. And some people, they don't know how to convert those units. But we're going to deal with that at the end when we're finished. So now, in these type of questions, what we must do is we must set up like a chain rule kind of thing, right? So first of all, we always write down what they're asking us to find. So the first thing I'm going to do is I'm going to write down what they're asking us to find. So it says find the rate of increase of depth of the water. Okay, so we want to find the rate of increase of the depth. And the depth, as we just said, is given by the letter X. So what we're trying to find, or what we're asked to find here is dx dt. Okay, so what we're trying to find here is dx dt. Okay, so we're finding dx dt. That's what we're trying to find. Then I always write down what we actually know, what they gave us some value of. And that is water is being pumped into the tank at a constant rate of 3.6 meters cubed per hour. So what they've given us is basically dV dt, 3.6. So I'll just write it as dV dt for now, and then we know that the value of this is 3.6. So they gave us dV dt. It's positive because it's going into the tank. If it says it was leaking from the tank, we'll put negative 3.6. It's going to be 3.6. Then I have to think now, this is where you've got to think a little bit. I've got to think, what do I have to multiply dV dt by such that I'll end up with dx dt? Okay, so first of all, there has to be a dx in the numerator in the end, so there must be a dx up here. And I have to end up with dt underneath, so this dv has to be eliminated, so it must be dx dv. If I multiply these together, I'm left with dx dt, the dv's will cancel out. So I know v is equal to 243 minus 1/3 times 9 minus x all cubed. So I can find dv dx. I can differentiate this with respect to x quite easily, dv dx. Okay, but I want to then write dx dv, which will be the reciprocal of this. So when I differentiate 243 minus 1/3 times 9 minus x to the power of 3, if I differentiate that with respect to x, the 243 will become 0. I'll have 3 times minus 1/3, which is minus 1. Then I'll have to take 1 from the power of the bracket. But remember, we have to use a chain rule because you have a function inside a function. 9 minus x is inside this function. So I have to multiply by the differential of what's inside. Don't forget that, which is going to be minus 1. So you end up with minus 1 times minus 1 is positive 1, so you end up with 9 minus x squared. That's dv dx. That is a value of dv dx. Okay, dv dx. So therefore we can say dx dv is going to be 1 over this. 1 over 9 minus x all squared. So I can therefore say that dx dt is equal to dv dt, which is 3.6, multiplied by dx dv, which is 1 over 9 minus x all squared. Okay, so that's dx dt. And I know we've got to find this when the depth is 4 meters. We've got to find what the rate of increase in the depth of the water is when the depth is 4 meters. So I'm going to replace the x, which is the depth, with 4 in this equation. So I can say dx dt is equal to 3.6 over, you're going to have 9 minus 4, which is 5 squared. So 3.6 over 5 squared. So you have 3.6 over 5 squared. That gives us 18 over 125, 18 over 125. Okay, so that is your answer for the dx/dt, but in meters per hour. Now we want to change it into centimeters per minute. How do we change it to centimeters per minute? Well, it's pretty simple. There's different ways you can think about it. One way is you can take 18 over 125. The numerator is in meters. You want to change it to centimeters, so you multiply by 100. And the denominator is in hours. You want to change it into minutes, so you multiply the denominator by 60. So it's going to be 18 times 100 over 125 times 60. So you end up with 18 times 100 over 125 times 60. Oops. 25 times 60, and that gives you 6 over 25, which is 0.24, 0.24, and that's now in centimeters per minute. There's the answer. We could also think about it as you take 18 over 125, and you want to convert from meters per hour to centimeters per minute. So the part that doesn't say per meters to centimeters, you multiply by 100, that's fine. And then the one that says it's after the word per hour to per minute, well, we normally multiply from hours to minutes by 60. But because it's after per, we divide by 60 instead. So you put divided by 60. Of course, it gives you the same answer, 0.24. So whichever way you want to think about it, that's fine. But don't forget about that situation where you have to read the question carefully. Okay, give your answers in centimeters. I'm sure many people didn't even read that part and they lost marks. Okay, so there's the answer to that question. Other questions from this particular paper can be found in the playlist that will appear over here. Other questions from the topic of differentiation you'll find in the playlist over here. And you can subscribe to my channel by clicking on this link here, and you can watch a video which is linked here, which will tell you how to use my channel to find things that you might be interested in. Thank you for watching, and see you soon.